Hello everyone. Welcome to MathPrax. In this video, I will show the solution to the challenge problem in the previous tutorial, and we will continue with our arithmetic progression problem-solving practice. Using the formula for finding the general term in an arithmetic sequence again and again is what will make it easy for you to solve problems in this topic. So let's go ahead and take a look at the previous tutorial's challenge problem. The fourth term of an arithmetic progression is 15, and the ninth term is 50. Now, for the purpose of demonstrating what I mentioned before about not having to use a sub 1 as the reference term in the formula, I will first show the solution to question number 2, which asks for the common difference. Since the fourth and the ninth terms are given, we can ask ourselves, how many times do I have to add the common difference to the fourth term in order to get to the ninth term? The formula would then turn to a sub 4 here and minus 4 there. Again, I will repeat the question. How many times do I have to add the common difference to the fourth term in order to get to the given term of n with a value of 9? Now let's put it to use. Ninth term of 50 for a sub n equals fourth term, which is 15, plus the quantity of 9 minus 4 multiplied by d. Transposing 15, this becomes 35. Cross multiply 9 minus 4, here goes the 5 there. This gives us a common difference of 7, confirming the answer I have already given above. Let's now answer question number 1. What is the second term? Here we can still stick to the same formula we used here. Since the second term precedes the fourth term, the value inside the parentheses will give us a negative value. The idea of the formula can then be rephrased to, how many times do I have to subtract the common difference from the fourth term in order to get to the second term? Again, simply substitute the values we have. A sub 2 is asked for equals 15 for a sub 4 plus the quantity of 2 minus 4 times the common difference of 7. Here, twice the common difference gets subtracted to 15 to get a sub 2. So the answer is 1. Third question. How many terms are there from 50 to 113? Here is a quick solution. We subtract the first term from the last term, divide that by the common difference, and then we add 1. This will give a value of 10, and so there are 10 terms from 50 to 113 in this specific arithmetic sequence. I hope you had fun solving this challenge problem. Let's go now to the main problem for this video. A group of robots is programmed to fill identical containers with water. Each robot in the sequence pours more water than the previous one, following an arithmetic pattern. Robot 1 fills 8 liters. Robot 2 fills 12 liters. Robot 3 fills 16 liters. Robot 4 fills 20 liters, and so on. How much water does the 10th robot pour? Remembering the formula, which values are ready for us here? If we look at the given information, we can easily tell that the common difference in the sequence is 4. Considering robot 1 amount as the first term, that gives us a sub 1 of 8. So we have a sub 1 and the common difference. And in the first question, we are asked the quantity the 10th robot pours. We are asked for the 10th term in the sequence. So a sub 10 equals 8 plus the quantity of 10 minus 1, multiplied by 4. So the 10th robot pours 44 liters. Second question. A robot pours 60 liters. Which robot is it? For this one, we are going to have to solve for the corresponding n for a sub n of 60. Again, substituting the values. 60 equals 8 plus the quantity of n minus 1 multiplied by 4. Simplifying the equation and solving for n gives 14. Third question. For which robot number does the amount of water first exceed 100 liters? There is a keyword here, first exceed. Since the common difference is 4 and the given terms here are as well divisible by 4, the amount of water should be the first number greater than 100, which is divisible by 4. That would simply be 104. Take that as the a sub n, 104 equals 8 plus the quantity of n minus 1 multiplied by 4. Simplifying the equation and solving for n gives 25. What if we are asked, How many liters are poured by the 25 robots altogether? The answer is 1,400. We will cover this in the next tutorials. Thank you for watching, and if you found this video helpful, please hit that subscribe button so you don't miss out on my next tutorials. I'll see you in the next one.